Hi everybody, this is Dino from Prehistoric Facts, and like I mentioned earlier in the special episode of Basilosaurus, you can actually check that out right now on YouTube. And we're actually gonna do an extra episode. And this extra episode, I've been requested to actually do an episode about sauropod evolution. And so that'll actually come in handy to actually help people understand how sauropods actually came into be in the Mesozoic. Now, when we look at the evolutionary family tree of sauropods, we actually see they actually have a carnivorous ancestor. And basically, the carnivorous ancestor is basically either Eoraptor or Herrerasaurus. And what paleontologists actually say is that Herrerasaurus probably was the one that actually arose from actually started the trend to actually become more of a herbivorous animals. So basically they actually kind of started out of actually becoming the sauropods and the other kinds of dinosaurs that actually came into be. But even though I think a lot of it too has to do with Eoraptor, but I think Eoraptor is probably the one that actually set the trend towards the Saurischians, which actually which the groups that include the sauropods and the theropods. And so basically, I think Eoraptor comes from that lineage, because you see Herrerasaurus would have actually gone to like the armored dinosaurs, and also probably the iguanodontids, and also you got the duck-billed dinosaurs. But let's actually get into how they actually kind of took off after that. And basically, after Eoraptor, you actually have a split in terms of where dinosaurs were actually going to go. And basically, the Saurischians went to different paths. One went to stayed in the carnivorous route. Basically, you have your theropods. And then basically the other side of it is actually start to go towards of a more herbivorous diet. And so there might have been a missing link in terms of what kind of herbivorous dinosaur is actually the trend of actually both herbivorous and carnivorous. But even though it probably was eating more plants than meat. So it probably could have actually almost looked like an animal, almost looked like Falcarius from the end of it. But Falcarius came from the Cretaceous. We're actually in the Triassic. In the Triassic, you actually have the beginning of the prosauropods. And the prosauropods are like like dinosaurs like Ankylosaurus, Massospondylus, Plateosaurus. You know, those are the kinds of dinosaurs that eventually became sauropods. Now, when we look at the fossil record, recently there has been a great find of actually showing what is really the first true sauropod, and so that actually kind of came in around the Triassic-Jurassic boundary, and so that actually happened during 2010. Paleontologists have actually unearthed a couple skeletons, but even though one of them is an intact skeleton with a complete skull, and that is Eusosaurus. And that dinosaur is technically going to be called the first true sauropod, but even though there's another candidate that isn't actually in Asia called Isanosaurus, but even though I don't think there's that much of it has been found, so I'm not totally sure about that one. And so the true sauropods actually began during the Triassic-Jurassic boundary. So how about that? They actually really came into be right in the beginning of the Jurassic. And so, but even though the prosauropods were still dominating, sauropods were still rare at that point. So basically, prosauropods were still dominating the early Jurassic. But when you get to the middle Jurassic, prosauropods are very rare, and then basically sauropods really dominated, and so really started to take off. Because the middle Jurassic is when sauropods were actually kind of starting to begin to be they were mainly medium sized. They were mainly medium sized, basically between 40 to 50 feet in length. because it wasn't until the beginning of the late Jurassic we actually start to see the diversity, a huge diversity of sauropods come into be, and that's where you get like your diplodocids, your brachiosaurids, and all those kinds of dinosaurs, even the chimerosaurids, and those kinds of dinosaurs. Because the more famous sauropods actually came from the Jurassic. You got Diplodocus, Brachiosaurus, Apatosaurus, and eventually Brontosaurus is going to come into this, and all sorts of other sauropods like Seismosaurus, all that sorts of stuff. And you see, those are the more famous sauropods, and the most famous sauropods actually were around in the Jurassic, and that's when you have all those. But you see, these kinds of sauropods actually ain't different kind of things. And you see, it's all based on the teeth and the shape of the skull and also the leg design. Because you see, diplodocids are actually more slender in terms of their body shape. They're more slender types of sauropods. Basically, they held their necks horizontally, and they have smaller skulls, and their teeth are kind of peg-like, kind of long and peg-like. So basically, they were not really actually going after things that are in the trees. So, because you see, they wouldn't even raise their necks high enough, raise their heads up high enough to actually reach the trees. Just because you see, there's no way, based on physics, that a sauropod like Apatosaurus or Diplodocus would actually raise its neck up to actually get its head up. In order to actually get anything in the trees. It could raise its head up just slightly, probably only like a 15-degree angle, but that's it. And so, and you see, there's not that much of curvature in the neck vertebrae. But then you actually get to the chimerosaurids, which are basically the chimerosaurids and the brachiosaurids, and you see a totally different kind of sauropods, and you see these are dinosaurs that have really long necks, shorter tails, and basically they have longer front limbs. And you see these are dinosaurs that probably actually they're kind of almost like giraffes basically, but how would they actually hold their necks? Basically, well, with Chimerosaurus it probably held its neck horizontally, whereas Brachiosaurus it probably did actually have its neck vertebrae. It looks like it actually held its neck in a diagonal angle. So probably it actually, and you see with Chimerosaurus and Brachiosaurus, they were actually stripping vegetation off trees. Now Chimerosaurus was probably both a ground level feeder and also a tree feeder. So, but you see Chimerosaurus's front limbs are nearly the same size as its back limbs, but when you look at Brachiosaurus, its front limbs are longer than its back limbs. Now, what does that really say? Well, you see, Brachiosaurus probably had stronger back legs, so basically could raise its body up probably in a much more effective way than Chimerosaurus or even Diplodocus or Apatosaurus. It's probably because the Brachiosaurids probably use their front limbs as defense. But you see, with sauropods, you actually have their size, and size is a really good weapon. And basically, once you're big, you don't really have that much of predators coming after you. It's because predators are too scared to go after something that's probably like as tall as a 3-story building, and then basically you actually are not going to go after that thing, because basically, how are you going to kill it? But then in the Jurassic, you actually start to. But now, continuing on with the evolutionary family tree, when the beginning of the Cretaceous, you actually see a decline in sauropods, and you see the decline is actually in the fact of actually how the northern hemisphere is actually changing. And you see, in the northern hemisphere, sauropods are very rare. And you see, that's when the era of the titanosaurs actually began. The era of the titanosaurs is basically, you have sauropods basically in the southern hemisphere. Basically, in South America, Africa, Madagascar, India. Not real. Some of it. Some of them in Australia, in Antarctica, but basically in some, and also in some parts of Asia. But when we look at that, there's a pattern there, and you see and that pattern is basically sauropods that actually lived in the southern hemisphere survived dramatic climate changes that survived, and basically there was a dramatic climate change in the northern hemisphere. And you see titanosaurs ruled the Cretaceous, and titanosaurs are much different than the brachiosaurids and the diplodocids. They're closely related to the diplodocids, but basically they're actually very different types of animals. And what we see here is that titanosaurs started to develop body armor in the back, basically bony scales, kind of bony scutes, kind of like in ankylosaurs, but basically not as developed as ankylosaurs. And so probably what they were doing is that since they were going to be facing bigger predators that were actually going to be attacking them, so probably what they were doing is actually developing a defense system right on their back. And so their back was actually there was a really good defense, and also their tails were long enough to actually whip the predators. And you see that's why you have the Carcharodontosaurs that were actually around at that time, like Mapusaurus, Giganotosaurus, and Carcharodontosaurus that were actually around at that time. And so, during 90 million years ago, we start to see a bigger decline. We start to see huge decline in sauropod population. It's because you see, during that time, ceratopsians and hadrosaurs were taking over, and you see ceratopsians and hadrosaurs could actually get to the vegetation that sauropods couldn't get, and so that really has a huge issue with sauropods. But then there's an interesting thing though that was actually happening. We see that some parts of some titanosaurs actually made it to North America, and you see that was because of Alamosaurus. And Alamosaurus is actually found in North America, in Mexico and Texas and New Mexico area, and that was one of the last sauropods. And you see titanosaurs were hanging on by a thread at that point, and when you're hanging on by a thread, that means you have a very low population in terms of the dinosaur world, and also you actually gotten smaller in size. Alamosaurus was not as big as Argentinosaurus. There was no way it was going to be as big as Argentinosaurus, and so Alamosaurus actually kind of shrank. Alamosaurus was one of those titanosaurs that shrank in size in terms probably like 10 to 20 feet in terms of height. Probably just 10 feet. But in length, it was drastic length reducement, and that was actually, and it was probably like a 20 to 30 feet difference compared to like Argentinosaurus. Argentinosaurus could actually get to over 100 feet in length, and so that actually has a big effect. And also it probably was coming into contact with predators all the time, and in the southern region of Mexico, and basically in the southern region of the United States, and also in northern Mexico, you got your big tyrannosaurs that were running around, and that was basically the southern forms of Tyrannosaurus rex that were actually attacking Alamosaurus, mainly the young. And predators that were adapted to killing sauropods actually had more thin slicing teeth. And you see, that's a better way to kill a sauropod, is bleed it to death. And so sauropods for their strengths and weaknesses, their strengths are basically their size, their muscle, their mass, and basically their tails, and also their front limbs. But their weaknesses are basically is that they don't really have that much of body armor, and also they're really exposed to and they're very vulnerable when they're young, old, and sick. And so when you're actually at that size when you're old and sick, you slow down, and also predators are actually gonna come after you. They are gonna easily pick that one off. And so sauropods they're the icons of the dinosaur world because of their massive size, their long necks, their long tails, and also you have the majestic of their size. And I mean, that's just amazing to look at a sauropod that is just tremendous in size. I've actually had the chance to actually got to see the Ultimate Dinosaurs exhibit last year. That actually was a special exhibit in the Science Museum of Minnesota, right in St. Paul, and I actually got to see a couple sauropod specimens, but even a couple of sauropod replica specimens. They were just replicas, basically. And one of the specimens was actually the one in Madagascar called Replicas, and you can totally see with isolation on an island, it shrank dramatically. And you see that actually has an effect. With smaller amount of food sources, you have to reduce in size, and that's happened to many dinosaurs that actually lived in smaller areas. And also I've seen a replica vertebrae of an Argentinosaurus, and it's massive. It's basically almost taller than I am. So basically, it's amazing to actually think a dinosaur that actually has really big vertebrae, and you're almost as tall as it. And so that actually is just amazing. And you see and also there's a lot of differences in feeding too with sauropods. You got your fern feeders, and also you got your tree feeders, and also you got your ones that are in between, like Camarasaurus. Camarasaurus is an in between type of sauropod, because like Apatosaurus, Brontosaurus, Diplodocus, they're basically ground level feeders, basically feeding on ferns, some parts of cycads, basically softer leaves is what they were going after, softer plant material, and they were stripping the leaves off the ferns, not really taking the whole fern and basically try to eat it up. And so that's actually a difference in digestion as well, because you see brachiosaurids probably, because since they were kind of slicing off some parts of the branches of trees, you actually have to eat, and that's tougher plant material than actually ferns. And so it's a big difference in terms of feeding. And I would actually say that in the Cretaceous, sauropods were in decline, basically pretty much throughout most of the Cretaceous. And that was surprised because of newer plant and new herbivorous dinosaurs coming into the scene, like the iguanodontids. Iguanodontids took over the planet like crazy in the Cretaceous. And so sauropods weren't really totally extinct at the end of the Jurassic. They survived, but they became titanosaurs because they got bigger in the southern continents. Basically the Gondwana continents, like South America, Africa, India, those kinds of places. It's because it's bigger land masses, and also you have much more room to roam around than in the Jurassic, where in the northern hemisphere you got the Diplodocus and Brachiosaurus and all those kinds of sauropods. And so sauropods pretty much went extinct at the same time as the final dinosaurs, and that was basically Alamosaurus was one of the last sauropods, and so pretty much died out the same way like all other non-avian dinosaurs actually did. And that was basically due to the asteroid strike in the Yucatan Peninsula in the Gulf of Mexico around 66 million years ago. Alright, that's it for now, and next week will be an Answering Questions episode. And so if you got a question about dinosaurs or any other prehistoric life, feel free to email me at dinochris71@gmail.com, or other ways you can go on the Facebook page, Prehistoric Facts with Dino Chris. Like the page, you can actually post a question on any Facebook post in the comments section. And also make sure to keep your questions short and to the point. And you can also follow me on Twitter at CSGRALL. That's my Twitter page. Follow me there, and I post pretty cool stuff there. And also take care of the people around you. And also for you younger people out there, make sure to listen to your parents, your teachers, and your guardians. So the best motivation you can have for a good education. It's very important to have a good education, because with a good education, you get a good job in the future. All right, that's it for now, and I'll see you guys next week.